Hello again, Rough as Guts Videos returns to your screen with more Linux stuff, specially suited to those of you who find the, quote, wall of text, quote, in Lab 1 altogether too much. So I'm going to talk about those things, hopefully fairly briefly. The hierarchical file system. I'm assuming, or I'm hoping, that most of you are familiar with this as an idea, at least. In Windows we have the hierarchical file system, except we actually have multiple ones. We have one starting at C:, D:, E:, and so on. Here they're all in one unified hierarchical file system, starting or rooted at this location called root, or just slash. So if I were to, actually I'm going to go clear, if I were to go list slash, then I get all of those, and you'll see these ones here are a subset of all the ones there. Bin is where some of the most important system binaries reside, such as bash, for example. ls/bin lets me see all of those. There's bash sitting there, and for somewhat historical reasons most of the binaries are actually not there at all. They're in here at userbin. So if I go list/userbin, I get an awful lot of files, and you might wonder how many, in which case I can go ls, or just ls/bin, /userbin, and pipe it into, so vertical bar calls pipe, push the output of that into this program called word count, which counts words, characters, and lines. Kind of useful, kind of not. And I discover there's 3,652 commands, all of which you are expected to know off by heart in time for the test. And I'm joking. Nobody knows all of the commands. There's a directory here called user include, so /user/include, which contains include files for the C compiler, and you'll be meeting some of those real soon now. /lib is library stuff, /home cosc staff and student is where your personal files and mine all reside. So that if, for example, I use that command I told you, cd, to change to the home directory. I was actually there already, but we'll do it again. And then I go print working directory, pwd. I get told I am at /home, /cosc, /staff, /rjl83. So I'm in here somewhere in a subdirectory called rjl83. If I were to go list/home, cosc, student, then you'd find all of those, and your name should be in there somewhere. Somewhere in there you'll find your name if you could be patient enough, and that's where all your files would be. There are a couple of other directories here called /dev and /proc, which are not actually directories at all. They're pseudo directories. They're cunning ways of getting at the individual devices on the system, such as disk, USB, and so on, and also cunning way of getting at the details of what processes are currently running. We don't need to know about those, except that I put them in there because I thought they were kind of cool fun. Your mileage may differ. I've covered all those. I'll move on. Files. You're familiar with the idea of files from COSC 121, I hope. As far as this course is concerned, programming in C, a file is 0 or more 8-bit bytes. Always 8 bits for use in C, at least for this course. The file names, if I go ls here, all the file names, or most of them, have a dot in them, followed by what we call the extension, which tells you the type of the file, just as in Windows. Windows tends to hide most of them from you. We don't hide stuff in this course. We're real computer science people, or engineers, of course, or anything else, with apologies to all those whose personal choice of career has just been omitted. So .csv, comma, separated value. So that, for example, if I want to look inside the file stylemarks.csv, I can do so by going less, which is a funny name for a command. It dumps a file. History doesn't matter. Style, no, I won't do style marks. Teams _ all.csv, and there I get the file listed. And now is as good a time as any to tell you about a couple of useful keys here. If I use down arrow, it goes down through the file one at a time. You'll note there's a colon prompt there. I can use the up arrow and go up it. I can use Control B to go backwards through the file, Control F to go forwards a page at a time. I can even type a slash and go looking for the, I don't know, EX word. Are there any words starting EX? Yes, there they are. So it's kind of useful for quick looks. So that's this business here. As far as the Linux file system is concerned, there's no distinction between binary files and text files. They're all just sequences of 8-bit bytes. It's just a convention that there is what's called an extension on the end. It doesn't have to be there. As you'll see, some files don't have an extension. There's one there that doesn't have any extension on it. And we've looked at how you refer to them as a path. There's a slide here on file protection. I did introduce this briefly in the first video on Don't Bash Bash. I'm not going to go through all of that in detail. It's there. You can freeze the video and look through it if it interests you. That tells you in detail what the different columns of information are when you do an ls-l. And lastly, some useful keyboard tips. I've mentioned a couple of them, the Control F and Control B, so let's start at the beginning here with the star. So if I do ls star, it lists all the files and in the current directory, and if they're themselves directories, then it lists the contents of the directories too. If I go ls f star, I get all of the files or directories beginning with F, including F itself. So star matches any sequence of characters, including the empty sequence. So F, find bad submissions.py and so forth, a file starting with an F, and there's also a directory starting with an F, which is feedback, and it gets listed separately. If I wanted to list all the files starting with FR, I could do that. If I wanted to list all the Python files, I could do ls-star.py. If I want to list all the .csv files, I can do that, and so on. Very useful to know about star. Also very useful to know about Control-C, particularly if your program gets stuck in a loop or you get sick of waiting for it to finish or whatever. So here's a program called top, which shows me all the processes that are currently running, and I can look at that for a bit until I'm bored. Then I can go Control-C and kill it. Up and down arrow, as I've mentioned, up and down arrow when you're inside a less listing or maybe a man page. They're also useful when you're just talking to bash directly, because they take you through the command history. Every time I go up arrow, I get the previous command. Down arrow takes me back down through them. And there's also, if you need it, a command called history, which lists them all so I can see what I've done recently. Another really useful key press is the tab key. So that if, for example, I want to run Python and I know I have a program called Weaver and I'm not a very good typist, I might think, oh, WE, I'm bored, hit tab. Blah, it auto-completes for me. Magic. Except, of course, if the WE isn't an unambiguous definition for the file. So let's, for example, instead I'm going to go Control-C. Let's go Python 3 W tab. At that point, you may or may not have heard there's a bell sound of some description, and that tells me that it's not unambiguous. If I hit tab again a second time, it tells me what all the possibilities are. So in this case, it could be weaver.py, or I could go on into the workspace or directory called workspace. So WO tab is now unambiguous, and it stops in that directory. If I hit tab again, it goes beep. If I hit it a second time, then I now get a list of all the possible continuations, any one of those. So I might go, for example, HE for hello Android. It does as much as it can up to hello, but then it doesn't know whether I mean hello linear or hello Android. It goes beep again, A, tab, and it completes, and so on. Very useful for quickly traversing or finding files. And that's all that I had on that slide. I'm going to call this video quits. Thanks for watching. Bye.